This particular question says write the ground state electron configuration. And here it says, and I will always try and be clear about this, complete, no abbreviations or noble gas cores of an atom of iron, Fe. Enter the entire electron configuration with one space between each sublevel and no superscripts like this, 1s2, 2s2, 2p6, etc., etc. Now, let's see. I need my periodic table here. I take out my periodic table. I see that iron is element number 26. That means that it has 26 protons. And for an atom, protons equals electrons, so that means it has 26 electrons. Now, the way that I do electron configurations is called according to the shape of the periodic table, and it goes like this. Start up here in the upper left. This is the 1s area. I can even write that. 1s. And then the 1s sublevel holds 2 electrons. That takes me all the way over to helium, since it's the second element. So I write 1s2. And believe it or not, my method of doing this is that whenever I get to the right-hand portion of the periodic table, like a classical typewriter, I go ding, and then I move back to the left-hand portion. This is the 2s area. It is 2 elements wide, and that means it is going to be 2s2. And I'm writing them as superscripts because that's typically how you'll see it in a textbook, online, or if we were writing it on paper face-to-face. 2 elements wide. Then we go straight across over to the 2p area. 2p is 6 elements wide. That means that 2p will hold up to 6 electrons. And now I have 10 electrons in my electron configuration. I've made it all the way over to element number 10. Ding, come back to the left-hand portion. Now I'm in the 3s area. And 3s is always 2. So there was 1s2, 2s2, 3s2, and we will keep going when we need to. Then we keep going to the 3p area. It is 6 electrons, 3p6. Ding, we're all the way over here at argon. Come back, 4s2. Now we have a total of 20 electrons. Remember, we don't want to go too far. We want to go to 26 electrons. And this 10 electron and 20 electron thing is not part of the answer. It's like my keeping track of my total number of electrons. Now I'm into the 3D area. And I'll write 3D in here. It's 4s and then 3D. And we have some talking to do about the relationship between 4s and 3D, as we will do. 3D, then comes 1, 2, 3, 4, 5, 6. And we end right on iron's block in the periodic table. And because there were 6 electrons into the 3D area, we get a superscript 6 there. Okay. And these are this is the electron configuration for the iron atom. And it is saying that these are the sublevels into which the electrons fall. Any questions about that? And jump in anytime if you do. So what I will say is, please do enter it in this order.
Professor?
Yes.
I did germanium for mine, and it looks like the correct answer and mine are exact, except one of the spaces is missing in one of your answers.
Thank you for letting me know.
So it's 3p6, and then there's no space between the 4s2 for the germanium one. So you can, hopefully that helps you figure out where the fix needs to be.
Thank you. That is a big help. Sorry about that, Selden.
Yep. Do you want me to just do another one?
I'm going to take a note to go back and look at yours. And I'll check. But yeah, so up to you.
Okay. I'll try another one and see if it fixes it.
I will say this. It should be fixed. And so I need to fix it anyway. But then the other thing I'll say is that I did copy and paste them. So it's probably the same for the next one.
Oh, okay. Sounds good.
Uh, 3p6, 4s2. Okay, so now we're going to talk a lot about the 4s and the 3d and which is lower and which is higher in energy. But I'm going to ask you to enter in this order, which is the order of the periodic table. Meaning that on the periodic table, 4s comes before 3d as we go from low to high number of elements. Okay. Anyway, any other questions about that?
Professor?
Yes.